Example 10. Find the critical numbers and intervals where the function is increasing and decreasing. This is for f of x equals x plus 6 to the 2/3. The first important thing to realize is that this is also a root. It is the cube root of x plus 6 squared. And since you can have a negative inside of a cube root, the domain of our function is not restricted at all. It's from negative infinity to positive infinity. So now we'll take our derivative, f prime of x is the power 2/3 times the base to the power minus 1, that's 2/3 minus 1, and then the derivative of our base is 1, but always think about that chain rule every time. So this is going to be 2/3 times x plus 6 to the negative 1/3. So that's going to be a 2 on top and a 3 times x plus 6 to the 1/3 in the denominator. So remember that the definition of a critical number were the values where f prime of x were equal to 0 or where f prime of x does not exist. And while 2 can never be 0, meaning f prime of x is never 0, this denominator would be 0 if x is equal to negative 6. So at negative 6, we would have 2 over 0, which means the derivative does not exist. But it is a critical number, just by definition, that critical numbers occur where the derivative is 0 or the derivative does not exist. And so we have one now where the derivative doesn't exist. That's the number negative 6. So what we have to do is we have to check values to the left of negative 6, like negative 10, and to the right of negative 6, like 0. So if I put this into the derivative, f prime of negative 10 is going to be 2 over 3 times negative 10 plus 6 to the 1/3. That's 2 over 3 times negative 4 to the 1/3. Now that's going to make this denominator a negative number, and a positive over a negative is a negative. So we have a negative interval to the left of negative 6. Now if we do f prime of 0, we'll get a 2 over a 3 times 0 plus 6 to the cube root. That's going to be 2 times a positive number, and you can find that value, but you don't have to. All we need to know is that this is positive, so this interval is a positive. So our critical number was x equals negative 6, and our function is increasing where the derivative is positive, so that's from negative 6 to infinity, and it's decreasing where our derivative is negative, so that's negative infinity to negative 6.